Welcome to True Projects. In this video, we are going to explain about the project that is Vision Transformers Ensemble Model and Transfer Learning leveraging explainable AI for brain tumor detection and classification. Before getting into the execution, first let us understand what is the project about. So these brain tumors, they are categorized by uncontrolled growth of cells. That means they cannot be controlled in the brain, which poses a significant threat to the health worldwide. And these tumors, they are classified into two types. One is primary and the other one is secondary. So coming to primary, the primary tumors, they originate in the brain itself. While coming to the secondary brain tumors, they are the metastatic tumors. They occur when cancer spreads from the other parts of the body to the brain. The latter is common, with several types of cancers, including lung, breast, and colon cancer, having the potential to metastatize to the brain. So, early and accurate detection of the brain tumor is critical for effective treatment, as early and accurate detection of brain tumors is very important, as the treatment approach varies depending on the type and location of the tumor. So, coming to this magnetic resonance images, so these has become one of the most widely used methods for detecting brain tumors. MRI is particularly effective because it provides detailed, high resolution images of the brain soft tissues, which makes it easier to detect even small or subtle tumors. However, we do have some challenges with this MRI images. So, there are challenges with this MRI images because they are time consuming and they require highly trained specialists. Even with the expertise, human error can occur, leading to inconsistencies in the diagnosis. Different doctors might interpret the same MRI scan in different ways, which sometimes results in misdiagnosis or delayed treatments. This highlights the need for more efficient, accurate, and reliable methods for brain tumor detection. By automating the analysis of MRI scans using advanced technologies, we can reduce the time spent on diagnosis and increase the accuracy for detecting tumors, ultimately improving the patient outcomes. Here, deep learning. So we have some deep learning models that has made significant strides in automating tasks like medical image analysis, including brain tumor detection in MRI scans. One of the challenges that researchers face, especially when the large data sets are not available, is that transfer learning models can be greater solution. So one of the challenges that researchers face, especially when large data sets are not available. At this time, transfer learning, they are the solution to this. So these models, which use pre-trained networks on a new problem, have shown great promise in improving classification accuracy when there is a limited data. However, there is downside. That downside is on single model is that it can lead to overfitting. Overfitting can happen when a model becomes too tailored to the specific data set and it is trained, making it less effective when dealing with the new unseen data. This can also cause the model this can also cause the model to become biased in its predictions, which is not ideal when you are trying to make a reliable diagnosis. So, to address these limitations, it is necessary to use a more robust, and that's where ensemble methods comes in. Instead of relying on just one model, an ensemble approach combines multiple models to make more accurate predictions. Think of it like getting second opinion from different specialists, and each model might have its strengths and weaknesses, but by combining their results, you end up with a more accurate and reliable outcome. This way, the performance of the system improves significantly, and it becomes better at classifying and detecting brain tumors in MRI scans. So, the project's goal is to create a more effective way to detect and classify brain tumors using MRI scans using a method called transfer learning. So, transfer learning is useful because it allows models that was already trained on one task and that is adopted for the another, often related task only, like analyzing medical images, even if there is limited data available. But instead of relying on just one model, which can sometimes be inaccurate or biased, here ensemble approach has been used. So the ensemble model here it is called as IVX16 and it combines the strengths of the top three models in transfer learning, that is all the three models together, and those three models are Inception V3, VGG9, VGG16, VGG16, Inception V3 and Exception models are combined in this IVX16 model. So think of it like having a team of experts with each other, each with their own area of expertise. Individually, each expert or model might have its limitations. But when they collaborate, they fill in each other's gap and provide a much more reliable and accurate outcome. In this case of IVX16, this ensemble approach leads to better accuracy in detecting and classifying different types of brain tumors. So here the system works by using the data set MRI images, we call it as MRI images, and the pre-trained models extract useful features from these images to classify them correctly. And the project evaluates several deep learning architectures that are VGG16, Inception V3, VGG19, ResNet 50, Inception V2, and Exception. They are evaluated. So by combining the strengths of these models, the IVX16 ensemble delivers a more accurate and robust solution for brain tumor detection, leading to better diagnostic results. So we will be comparing all these three models with the proposed model, that is IVX16. So this is the proposed system. Moving on to the extension part. So, to further improve the accuracy of classifying the brain tumor, here as an extension, we are incorporating multiple models that are NASNet Mobile and NASNet Large. We added to enhance the analysis of the MRA dataset. So these models are designed to be lightweight yet powerful, and by incorporating them, the system was able to process the data more efficiently while boosting the overall accuracy. Essentially, these models helps to improve systems' ability to identify brain tumors more accurately, even with the limited data or computational resources. And in addition to this project, we have also added a detection part of abnormalities within MRI images. Initially, in the proposed system, we have only just classified what is that brain tumor. But in this extension, we will be pinpointing where that tumor is on that MRI images. So to achieve this, I mean to implement this, we have incorporated YOLO model that we call it as you only look once, various versions of the YOLO. So YOLO is known for its ability to detect objects in images quickly and accurately, and in this case, it is used to locate and identify the tumor regions within the MRI scans. This significantly improves the system's ability to pinpoint where the tumor is located in the brain, making the detection process more precise and reliable. And we have developed front end using Flash framework. So this allows users to interact with the system and input MRI images for analysis. The interface includes user authentication. So it includes user authentication. So this allows users to access the system securely and privately. So the system includes user authentication, ensuring that only authorized individuals can access the system, which is crucial for maintaining privacy and security. So this user interface provides a seamless experience for anyone using the system, allowing them to easily submit images and receive tumor detection results in straightforward manner. So this is the extension part. Now coming to the implementation. To implement this project, we have followed different set of steps. So to classify the brain tumor, we have followed these set of steps, and for detection, we have followed these set of steps. And these are for front end. Now let us understand how we have implemented the project. So coming to classification, first what we have done is we have imported all the required necessary libraries and tools for the project, such as TensorFlow, Keras, and the other essential deep learning packages. And then comes exploring the data set. So here, at this stage, the data set of MRI images is examined to understand the structure, number of images, and labels. This helps in setting up the model for training. Then comes data augmentation part. So to improve the model performance and make it more generalizable, various image augmentation techniques are applied. So what we do is we rescale the image. So the images are sized to the appropriate scale, ensuring they fit to the model's input dimensions. And then we have applied geotransformation. This involves slightly tilting the images to simulate real world conditions. Then comes zooming the image. So random zooming is applied to make the model more robust to scale variations. Then comes horizontal flip. The images are flipped horizontally to artificially creating a more data, helps the model to generalize better. Then comes reshaping. So finally, the images are reshaped to the image dimensions expected by the model. Then comes defining early stopping. So to prevent the overfitting and underfitting, early stopping is implemented. This monitors the model performance and then stops the training when the performance on validation set starts degrading. And then we call the model where we choose the deep learning model and we define all the layers. Then comes building and training. So the model is built by stacking layers and then trained on the prepared data set. So during training, the model learns to classify the brain tumor images into different categories. Then comes dumping the best model. So after training, the best performing model is saved. That is for later use in the classification task. This is how we have done classification. And then moving on to the detection part. So according to similar to classification, we have also imported necessary libraries and packages for detection also. Then comes exploratory data analysis. So here the images are loaded into the memory for further processing and the images are displayed to examine their content. And then comes image processing where we convert images into blob format which is compatible with the object detection models. Then comes defining the models, defining the class. So here the class or the categories of tumors are defined. Then comes declaring the bounding box. So here bounding boxes are drawn around the areas of interest within the image. Then comes converting. So this step converts the image data to an array format that can be processed by the model. Then comes loading the pre-trained model. So your pre-trained YOLO model architecture will be loaded. The layer of the model are read to understand its structure, and then the output layers are responsible for detecting objects are extracted. Then comes image processing where we append the image and annotation files. So it is the image and its corresponding annotation, that is bounding boxes, are linked. Then comes converting BGR to RGB. So the image is converted from BGR format using OpenCV to RGB. Then comes creating the mask. So a mask is created to isolate the tumor region. And then comes resizing the image. So the image is resized to match the input required for the detection model. Then comes data augmentation. So similar to classification, augmentation techniques are applied to create more variations in the data. Then comes randomizing the image here. So random transformations are applied to prevent the model from overfitting to specific patterns. Coming to rotating the image, so the images are rotated to account for different orientations. Transforming the image. So here other transformations are applied to make the model more robust. And then comes installing the required packages, and here the necessary packages for object detection are installed if not already present. Then comes building the model. So here model architecture of detection is built with which can identify and localize tumors in MRI scans. Then comes training the model. So here the model is trained on the pre-processed image to detect abnormalities such as tumors. Then the best version of the YOLO will be saved for future detection of tumor. Coming to the part of front end. So here the user interface is created using the Flash framework. This allows users to interact with the system, upload images and view results. And here users user authentication is set up using SQLite to ensure that only authorized users can access the system. Here users can log in and get registered. And users they can upload brain tumor images for classification and for the detection purpose. And that given images it will be pre-processed at the backend. It will be fed to the trained model, and finally outcome will be displayed to the front end of the application. So this is how we have implemented the project. Now coming to the algorithms used, these are the set of algorithms used for classification of brain tumor. So this is the proposed model and this is the extension model. And coming to the detection, these are the different versions of the YOLO that we have used in this project. Coming to the requirements to implement this project, we need basic requirements which are hardware and software. So we need operating system of Windows, processor of i5 and above, RAM of 8 GB and hard disk of 20 GB, 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, and JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. So to execute, we need to open the code folder which contains source code file. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this folder, we have the dataset that is used in this project for classification. Let's open the training folder. So here we have four categories in this project that we will be classifying, that is glioma, brain tumor, meningioma, pituitary and no tumor. So all the images are in their respective folders. Let's open the glioma folder. So these are the brain MRI images where glioma brain tumor is present. Let's get back. Accordingly, here we have MRI images of meningioma. And here in this folder, we have MRI images where there is no brain tumor. And here we have pituitary brain tumor. Let's get back. So all these images which are in the training folder are used to train the model for classifying the brain tumor. And images which are in the testing folder are used to evaluate the model performance on this unseen data. So these are the images. Similar images we have in training and testing, but images which are in training we will be using for training. Images which are in testing will be using for testing purpose. Let's get back. And here in the model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. And here in the sample folder, we have images in classification and also in detection. So images which are in classification, we will be using for classification, and images which are in detection, we will be using for detection in the front end to do the testing. Let's get back. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Here we have templates folder. So this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in the YOLO v5 folder, we have two more subfolders. So here we have two more subfolders. One is train and the other one is valid. Images which are in train folder are used to train the model, and images which are in validation folder are used to evaluate. Let us open the train folder. Here we have two more subfolders. One is images and the other one is labels. Let us open images. So these are the brain MRI images which are used to train the YOLO V5 model to detect the brain tumors. So using these images, we will be training the YOLO V5. So we will be detecting brain tumor, right? That locations will be in this label folder. So this label folder have the files containing annotations or labels for the objects in the corresponding images. So for all these images, we have annotation files in this label folder. Let's open it. Here, each label file, it corresponds to an image in the image folder. For example, this first image, it corresponds to the first label file, it corresponds to the first image file in the image folder. So it corresponds to this, which provides object locations. That is the brain tumor locations of this image. So we will be detecting brain tumor, right? Drawing a bounding box. So that locations will be in that label file. Similarly, for the second image, object locations will be having in the second label file. Accordingly, all the images which are 645, for all those images, we have total 645 annotation files. So these YOLO files, they follow the YOLO format. Let's open a file. So here, this line represents a detected object in the image. So here, this is the object class index. It is followed by its bounding box coordinates, which are x limit, y limit, width, and the height. So similarly, we will be having in all the annotation files. Let's get back. Similarly, we will be having in validation also. So we will be using validation folder to evaluate the YOLO V5 model. Let's get back. And here, same images we do have in YOLO V8 and YOLO V9, but they are annotated differently because each YOLO version requires its own specific type of annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives correct annotations it needs to function properly. So these images which are in YOLO V5, YOLO V8, and YOLO V9 we will be using for detection, and images which are in brain tumor MRI will be used for classification purpose. Coming to app.py file, so this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is also the model file. These are the Jupyter notebook files which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So in this Jupyter notebook file, we will be loading images for classification, and we will be training for classification only. And here in the detection, we will be loading the images which are in YOLO V5, YOLO V8, and YOLO V9. And we will be training all the YOLO models for the detection purpose. And this is the signup.db file. This file is a database file which is used to store the user information. So this is used to store the user information. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open Anaconda prompt. It is open. Give the command cd, give the space, and paste the copied path. Now click on enter. So this command is used to change the current directory to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This command is used to execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash Framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So just wait for a while, link will be generated, that is localhost will be generated. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project which is developed using Flask framework. We need to get signed up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to classification page of the project. So we will be doing classification and detection. First, let's do classification. So click on classification. So here you can see a choose file button, right? We need to click on that for uploading the brain MRI images for classifying brain tumor. Click on that. So we are supposed to open sample folder because in that we have test cases. Open that. Now we're doing classifications. Open classification. Let's upload images from these folders. So let's upload images which are in glioma and see whether the application will correctly predict it or not. So let's upload this image. Click on open. It has been loaded. Now click on upload. So this given image, it will be pre-processed at the backend and then it will be fed to the train model. Train model will be giving us the classification of the brain tumor. So just wait for a while. It is being processed at the backend. So here we got the prediction. This is the uploaded image. So this is the image that we have uploaded. And here we got the prediction that patient has glioma brain tumor based on the uploaded image. So this is the uploaded image. And here we got the prediction that patient has brain tumor of glioma. Let's try predicting some more images of the same class. So now let's upload this one. Click on open and now upload it. So here we got the prediction. This is the uploaded image. And here we got the prediction that glioma brain tumor has been predicted based on the uploaded image. Let's try predicting images from the other classes. So get back. Let us open meningioma. Let's upload the first image. Click on open and now upload it. So here we got the prediction. This is the uploaded image and here we got the prediction as patient has meningioma brain tumor. So the patient has meningioma brain tumor based on the uploaded image. So let's try predicting one more image from the same class. Let us upload this one. Click on upload. So here we got the prediction. This is the uploaded image and here we got the prediction that meningioma brain tumor has been predicted. So based on the uploaded brain MRI image, the application has classified that patient has meningioma brain tumor. Let's try uploading some more images of other classes. Get back. Let us upload no tumor. Let's upload the first one. Click on open and now upload it. So here we got the prediction. This is the first, this is the brain MRI image and here we got the prediction as no brain tumor. Patient has no brain tumor based on the uploaded brain MRI. Let's try uploading one more. Click on choose file. So now let's upload this one. So here we got the prediction. This is the uploaded image and here we got the prediction as patient has no brain tumor. Let's try uploading the last class of this classification. So let's upload this image. Click on open and now upload it. So here we got the prediction. This is the brain MRI image that we have uploaded. And here we got prediction as patient has pituitary brain tumor. It has been predicted as patient has pituitary brain tumor. Let us upload last image for classification. Let's upload this one and click on upload. So here we got the prediction. So based on the uploaded image, patient has been predicted with the pituitary brain tumor. You can observe, right? So now let's do the detection. Click on detection. So what is difference between classification and detection is coming to classification, we just give the image and application will tell what is that disease affected by the person. That's it. And coming to the detection, it will tell what is that disease and it will also pinpoint where the disease on the images. So that is the difference between classification and detection. Now let's upload the images. Click on choose file. Open the sample folder and open the detection. So let's upload the first image. Click on open and now click on upload. So here also image will be pre-processed at the backend and it will be fed to the trained YOLO model and then we will be getting the prediction. So here we got the detection. So this is the area where glioma is present. This is the part where the tumor is present, glioma brain tumor is present. And this is the probability score, that is how accurate the detection is. It is the confidence level that how accurate the detection is. Let's get back and upload some more images. And now let's upload this one. Click on open and now upload it. So here we can observe that this is a place where tumor is present. So here you can observe, right? Glioma is present and drawn in a blue color bounding box. Let's upload some more. Click on choose file. And now let's upload this one. Sorry. Let's upload this one. Click on open and now upload it. So here you can observe, right? This is the place where tumor is present and it is drawn in a blue color bounding box. So this is the place where meningioma is present. And here it is being highlighted in the blue color bounding box with a 0.68 probability score. Let us upload some more. So now let's upload this image. Sorry, let's upload this image. Click on open and now upload it. So here you can observe that pituitary brain tumor has been detected. So this is a place where this is the tissue where brain tumor is present, and here you can observe that pituitary brain tumor has been detected. Let's get back. Click on choose file. So now let's upload this image. Click on open and now upload it. So as there is no tumor present, here it is detecting as there is no tumor in the brain MRI. You can observe that it is drawn in a white color bounding box. Let us upload some more. So now let's upload this one. Here you can observe that meningioma brain tumor has been detected. So this is a brain MRI, and here you can observe that meningioma brain tumor has been detected. Let's get back. Click on choose file. And now let's upload this image. Click on open and now upload it. So from the image, we can observe that we got the detection that there is no brain tumor. Let us upload last image. Let's upload this image. Click on open and now upload it. So here, this is the place where tumor is present and that has been detected as pituitary brain tumor, and a green color bounding box is drawn around it. Let's get back. Now let's check with the graphs. Click on graph. So here the first graph we have is for the classification graphs. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained for classification purpose. And this is the precision score comparison graph. This is the recall score comparison graph. This is the FN score comparison graph. And here we have graphs of detection. So this is the precision confidence curve graph. This is the recall confidence curve graph, FN score confidence curve graph, and this is the confusion matrix. And here we have precision score for detection. This is the recall score comparison graph, and this is the mean average precision. So here you can observe that on x-axis we have mean average precision, and on y-axis we have all the algorithms that are trained. So for classification, we use accuracy, precision, recall, and FN score to evaluate. And coming to the part of detection, we use mean average precision, and recall. So this is all about the project. Click on sign out. In this way, just by uploading images to the application, we can, application will predict whether a person has which kind of brain tumor it is. If he has no brain tumor, it will detect as no brain tumor. If he has brain tumor, it will detect which type of brain tumor it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.